In this video, we're going to learn how what we've been looking at with the shot put problem and the candy problem can be formalized using systems of equations and substitution. So these are two things we're going to look at today, systems of equations and substitution. And we're going to try to use that instead of guessing and checking. And you started to discover this already on Monday. So the problem that we looked at Monday was two sizes of chocolate candy packages, a small and a large. The total number of chocolate candies when you combine a small and a large is 14. We don't know how much is in each small and a large, but we know if you combine them, you get 14. The total number, if you have three smalls and two larges, is 32. So can you figure out that puzzle and find out how much is in one small and one large? So this is what we did. You have a small and a large package. We know if you put those together, you get 14. If you had two larges and three smalls, you would get 32. Now, we can also symbolize that as kind of a picture, right? Rather than using actual pictures of candy, we could just draw a little box with L and a small box with S. So another way to represent a large and a small being 14 is this. And you could show two larges and three smalls like this. It's just a little simpler rather than drawing an actual or finding an actual picture of candy. Now, what we know is that what you guys discovered is that you can combine a large and a small and combine another large and a small. And we know that each of those give us 14, right? So we kind of paired those off and created our sets of 14. Well, if those packages equal 14, then I know since I have two sets of them, that's really 28 candies. But I have that extra small, and that basically means I must have four more candies. So if you pair off those larges and smalls, you get 28. But since I know I have 32 and the only thing left is that one little small package, that small package must have four in it. Well, once I know that a small package has four, and if I know if you combine a large and a small, you get 14, then I know the big had to be 10, right? Because 10 plus 4 is 14. And there you go. There's your answer. Just given some information, you can go back and figure out how much must be in a small and must be in a large. Well, let's revisit this problem, right? Rather than having to draw those big pictures, is there a way to do it without guessing and checking and without drawing those big pictures? Well, there is. So we have a large and a small and equals 14. Well, let's call a large L. Instead of drawing a picture, let's just call it letter L. And we can add that to a small, which we'll call letter S. So we don't even need pictures, we can use variables. So one large plus one small equals 14. There's an algebraic equation. Well, let's look at the next situation, which is we know two larges and three smalls equal 32. Well, how would you write that? Well, now we have 2L, 2 times L, plus 3 times S, 3 smalls. And if you add those together, you would get 32. So there's another equation, 2L plus 3S equals 32. Well, when you put those two equations together, L plus S equals 14, and 2L plus 3S equals 32, we call that a system of equations, because a system is when multiple things are working together and we have equations. So you have a system of equations. Problem is we have two variables, and unless you guess and check, you can't solve these equations straight away. So this is one way to solve them rather than guessing and checking. If we think about the second equation, 2L plus 3S equals 32. We're going to put the first equation on the back burner for a second and focus on the blue one. So if we focus on that blue equation, we could break that down and really say 2L plus 3S is the same thing as L plus S plus S plus S plus S. That's the same thing, just expand it out a little bit. Well, we can combine some L and S's, and it looks like we could make two pairs of L and S, right? We could get an L and an S together, another L and an S together, and then there would be that extra S, right? This L and this S, this L and this S can combine, and we have that extra S. I haven't changed anything. I'm just rearranging parts. Well, see, there's that L and that S. There's that L and that S. I combine them. I have that extra S. You see where that equation came from. Well, now that I have this, I can do something called substitution because I know L plus S is 14, right? Remember way back, L plus S is 14, but now I have an L plus S. So instead of using L plus S, I can substitute 14 instead of using L plus S. So whenever I saw L plus S, I plugged in a 14. I saw two of them, so I did 14 plus S equals 32. Well, now I have one variable, and I can solve this just like you did last year. I know that 14 plus 14 is 28. Now I can do inverse operations, subtract 28 from both sides, and S is 4, which we already know it is, but now we can solve that without having to draw those pictures. But we still want to know what a large package is. Well, do substitution again. Go back to that equation, L plus S. Well, now I know S is 4, so I'm going to use 4 instead of S. So instead of L plus S equals 14, I have L plus 4 equals 14. Well, now I have a one-step equation. Subtract 4 from both sides. L is 10. Now, what does that mean? It means each small bag has 4 candies. Each big bag has 10 candies. Does that make sense? Well, 10 plus 4 is 14, which should be true. And 2 10s and 3 4s does equal 32. So that works. Let's do one more example. So I'm going to have you the same exact situation, except what if one small and one large is 15 and 3 small and 4 larges is 54? Well, let's go straight to the system of equations, right? A large and a small is 15. So L plus S equals 15 now. 4 larges and 3 smalls equals 54. So you would write that 4 larges plus 3 smalls equals 54. Well, how do we write that system of equations? It's just both of those equations together. L plus S equals 15. 4L plus 3S equals 54. Now, let's focus on that second equation. Let's break it down. 4L plus 3S equals 54 is really L plus L plus L plus L plus S plus S plus S equals 54. Now let's pair off the L plus S's. Looks like we can make 3 pairs, right? There's a pair, there's a pair, there's a pair. But then there's that extra L off to the side, right over here. So there he is. So I have 3 pairs of L plus S's plus an extra L. Well, now I can use substitution again because I know L plus S is 15 in this problem. So every time I see L plus S, I'm going to use 15 instead of L plus S. So now I have 15 plus 15 plus 15 equals L. I'm sorry, plus L equals 54. Well, I can combine 15 plus 15 plus 15 as 45, and now it's a one-step equation. Subtract 45 from both sides, L equals 9. Well, now that I know L is 9, I can use substitution again. Instead of using L, I'm going to use 9 because I know L is equal to 9. So I plug in 9. It's a one-step equation. Subtract 9, S equals 6. What does that mean? Each small bag has 6 candies. Each big bag has 9 candies. I double check it. 9 plus 6 does equal 15. 4 9s and 3 6s does equal 54. And that is that. Substitution is when you plug in a value for another value that you know is equivalent. Systems of equations are when you have 2 equations that are happening at the same time. Hello?